All right, last section of chapter 2. We are now going to be talking about proving geometric relationships. So we talked about proving using the different property of equalities like the addition, subtraction, multiplication, division, properties of equality, some of those different things. And then last time we talked about using like angle and segment relationships. So we talked about angle bisector or the midpoint of a segment, things like that. Today we're going to be talking about geometric relationships. So if you kind of think back, we've talked about like perpendicular, like two lines can be perpendicular, forming a 90-degree angle. We also talked about vertical angles and linear pairs. So those are some relationships that we've kind of discussed before. So we're going to use some of those terms today to help us in our proofs. So let's get going. All right, so our first proof, we are asked to give, or we are given angle 1 and angle 2 are right angles. So if you look over to the side, they give us a kind of a picture there. They say angle 1 and angle 2 are right angles. And so I'm going to go ahead and just draw that on there. Draw that little right angle symbol. And in my first line, of course, I'm going to say angle 1 and angle 2 are right angles. And as always, my first line has a reason as given. All right, next, I'm going to try to eventually get down to my last line where angle 1 and angle 2 are congruent to each other. Now, you should kind of already think that's true because you see that we have two right angles and all right angles equal 90, and therefore angle 1 and angle 2 of course are going to end up being congruent. But we have to kind of logically walk through those different steps. So if angle 1 and angle 2 are right angles, what do you know about them? Well, of course, angle 1 and angle 2 are also 90 degrees, right? So angle 1 equals 90 degrees and angle 2 also equals 90 degrees. And how do we know that they're 90 degrees? Well, because that is the definition of a right angle. Okay, and so if angle 1 is 90, angle 2 is 90, would it be fair to say angle 1 equals angle 2? Now you have to come up with a reason, right? If angle 1 is 90 and angle 2 is 90, we have two different items that are equal to the same thing. So those two different items must be equal. Remember, that's the transitive property. Now I'm using POE, property of equality, because these two things here are equal. So then my last line is angle 1 is now congruent to angle 2. And that is the congruence property or property of congruency, however you want to word that. All right, one down. Next, we have segment AB. I'm just going to go ahead and start writing that. AB is perpendicular to BC. Now pause real fast and draw that in your picture. We have AB is perpendicular to BC. So let's mark that right there with a 90-degree angle. We also have that segment AD is perpendicular to segment DC. So AD and DC are perpendicular. So let's draw our little right angle. And I've already written it over here. Those are both the givens. Okay, eventually we want to get down to angle BD, or angle B being congruent to angle D. So we know that angle B equals 90 and angle D equals 90. Because that's what it means to be perpendicular, right? They form a right angle or a 90-degree angle. So that's a definition of perpendicular. I don't want to say definition of right angle because there wasn't anything up here about a right angle. All it said in the given was the word, well, the symbol perpendicular. So be careful to use the terms that they give you. All right, and so of course, kind of like our last proof, we're almost at an identical spot here. We see angle B, of course, is equal to angle, my goodness, I can't write. Angle B is equal to angle D, and that's the transitive property again. Property of equality, and because both of them were 90, then B was equal to D. And then of course, our very last line of our proof is the property of congruency or congruence property. And as always, you'll check that this matches with what you're trying to prove. All right, next. Now, these are all things we've actually talked about before, but we haven't really applied them to like a theorem. So theorem 2.3 says right angles congruence theorem. It basically just says all right angles are congruent. This is kind of like one of those no duh situations, right? Like, duh, I knew that. If angle 1 is a 90-degree angle and angle 2 is a 90-degree angle, of course their measurements are equal, which is the same idea as saying they are congruent. The angles are the same measurement. So 2.4 is the congruent supplements theorem. If two angles are supplementary to the same angle, then they are congruent. So if angle 1 plus angle 2 equals 180, and angle 2 plus angle 3 equals 180, then we can say angle 1 and angle 3 must be equal to each other. And if you look over on the diagram there, it almost makes more sense here. If you look at this straight line, we have that these two angles here are supplementary because they're a linear pair. But then if you look at this line here, we see the same thing, right? We see a linear pair. And so since both of those two sets include angle 2, then angle 1 and angle 3 end up being congruent to each other. And then the last one here, it says if two angles are complementary to the same angles, then they are congruent. So it's very similar. If angle 4 plus angle 5 equals 90, and then angle 5 plus angle 6 equals 90, well then essentially angle 4 has to be equal to angle 6 because that's the only way that they would both include angle 5. And so you can kind of see in the diagram here, almost looking at like these as a right angle here, angle 4 and 5 would end up being 90. And then if you kind of could imagine angle 5 being right here as well, then angle 5 and 6 would also make 90. And so you can kind of see how that would add up. Next, we have the linear pair postulate. This says if two angles form a linear pair, then they are supplementary. This is something that we've talked about in the past because, of course, any straight line is 180 degrees. They must end up being supplementary. And then the vertical angle congruence theorem. Now, you might have caught on to this, but we haven't actually mentioned this. It says that vertical angles are congruent. Now, what angles in that diagram are vertical? Angle 1 is congruent to angle 3, right? Those are vertical angles. And then we also have angle 2 is congruent to angle 4 because these are vertical angles as well. So any set of vertical angles are congruent. So using those ideas here, we're going to kind of do some examples. So it says use a diagram and the given angle measure to find the other three angle measures. So it says the measure of angle 3 is 128 degrees. So this is 128. We know based on vertical angles that this must also be 128, right? And then if you think about your linear pairs here, I have a linear pair this way with angle 1 and 2. So if this is 128, all I need to do is subtract from 180, and I would get 52 degrees here. And then if that's 52, these are vertical, right? And so this must also be 52 degrees. All right, next. What type of angles are in the diagram? Also find x. So what kind of angles are these? These here, of course, are vertical. And what do you know about vertical angles? You know they are congruent. So 101 must be equal to 4x minus 3. So I'm going to add 3 to both sides using the addition property of equality. And then I'm going to divide both sides by 4. Using the division property of equality. I'm actually going to even go one step further and switch that around using the symmetric property of equality. Now, if I wanted to, I could have made this into a proof, right? Could have had all these lines here on a proof. This would be my given. The next line would be addition property of equality. The next line is division property of equality. And then the last line there would be the symmetric property of equality. Now, it didn't ask you to do that. That was just for fun. So there's our answer, x equals 26. Next one, same question, what kind of angles are in the diagram? These, of course, are on a straight line here, and so that would be considered a linear pair. We know that all linear pairs are supplementary, and so 6x plus 2 is added to 19x plus 3, and they have to total 180 degrees. So don't set them equal to each other. They don't even look equal, right? We've got this little one here, and we've got this larger angle here. They are not equal. I'll tell you, every year people set these equal. I'm like, they don't even look equal, man. All right, next we're going to combine our like terms. 6x and 19x, of course, is 25x. 2 and 3 is 5. If I subtract 5 to the other side, I get 175. If I divide by 25 on both sides, I get 7, x equals 7. Make sure that I answer the question, right? It says solve for x, so we're done. But if it ever says to find the two angle measurements, make sure you plug your x back in. All right, last one is to solve for x and solve for y. Now, first of all, if I go across this way to do a linear pair, can I solve this? Not really, because I have an x and a y. Okay, what if I went this direction? Can I solve it? Again, no, because I have an x and a y. So you have to think about what's convenient here. Do you notice if I go across this way, I do have x's, and if I go this way, I have y's. So in this case, we don't want to use linear pairs. We want to use our vertical angles. So I know that 5y is equal to 7y minus 34 because of vertical angles. If I subtract 7y to the other side, I have negative 2y equals negative 34. If I divide by negative 2, I get 17 for y. Then if there are multiple ways of solving this, to find this angle here and here, those are also vertical, making them equal. If I subtract 8x from both sides, I get an x. If I add 4, I get 11. So those are our two answers. Now, there were other ways of solving this. Once I got this answer for y, technically I could have plugged that in up here to get what y, or what that angle is, and then I could have used my linear pairs, right? Because I would have known what this angle is, and I could have subtracted from wanting to find this x here. So multiple ways of doing the same problem if you prefer to do it with linear pairs. All right, that is it for us today. Of course, as always, if you have any questions, make sure to email us and let us know. Have a great day, guys. See you later.